All right, lecture 6. This is going to be simplifying rational expressions. Okay, so when we simplify rational expressions, what we're going to be talking about is we're going to be talking about something that is a fraction. Something that is a fraction. So let's take a look at it this way. Let's start off with a definition. We're going to define rational expression. All right, a rational expression. This is going to be an expression with both a numerator and a denominator. All right, so basically a numerator is what's on top, and a denominator is what's going to be on the bottom of the fraction. So you're always going to have a top and you're going to have a bottom. Let me show you what that looks like. So we're going to be talking about r of x. R of x is just a function, right? A function of x, where we're going to have a polynomial on top. Let's call it p of x. That's going to be the numerator because it's on top. And we're going to have a denominator on the bottom. We can call that q of x. Q of x. Where the denominator q of x cannot be equal to 0. All right, so think about it. You've got a top polynomial and you've got a bottom polynomial. Those are called the numerator and the denominator. And the denominator cannot be equal to 0 because what would that mean? Well, if your bottom is 0, then technically aren't you dividing by 0, right? So that's the reason why the denominator cannot be equal to 0 at all. Okay? Let's go ahead and get started with some of the notes. This is the first one I wanted to do. All right, let's say we have x plus 3, x minus 7, and then on the bottom, I have x minus 7 and x plus 4. All right, so what we're going to have is we're going to have a top part that's called the numerator. It's going to be x plus 3, x minus 7. And we have a bottom part that's called the denominator. We have x minus 7 and x plus 4. And the whole trick to this is making sure that you cross out factors, but only if they're on the same, if they're the same on the top and bottom. So on the top, I have x minus 7. On the bottom, I have x minus 7. Those match up, so I can cross them out. So then once I cross them out, the only thing I have left on the top now is x plus 3, right? So that's going to be my new numerator. And then on the bottom, I only have x plus 4. And I'm done. There's nothing left that I can still cross out. So that's going to be it. X plus 3 over x plus 4. Let's do another one like that. All right, let's say I have x plus 4 on the top. And on the bottom, I have x squared plus 7x plus 12. All right, so on most of these, what you're going to have to do is you're going to have to factor the top, and then you're going to have to factor the bottom. Well, the top is already factored. We can't really do anything more to that x plus 4 on top. So we're going to leave it the way it is. But on the bottom, can we factor this? I think about the two numbers that'll multiply to 12. So we're going to multiply to 12. But at the same time, we always have to add up to that middle number, right? I'm trying to add up to 7. The two numbers that'll do that are going to be 3 and 4. So now I know how to factor the bottom part. It's going to be x plus 3, x plus 4. So I can write it like this. So the top hasn't changed. But on the bottom, I'm going to write it as x plus 3 and x plus 4. Okay. So do you see anything that matches up on the top and bottom? It's that x plus 4, right? So I can cross those out. If they're the same on the top and bottom, I can cross them out. So now what do I have left on the bottom? I have x plus 3. And on the top, I don't have anything left at all. So I need to leave a placeholder 1. And I'm done. Okay. So if you don't have anything left at the top, you're going to leave a 1 in its place. And if you don't have anything left on the bottom, then you're going to leave a 1 in its place. Okay. Let's try number 3 on the notes. All right, I have x squared plus 8x plus 15. And then on the bottom, I have x plus 3, right? So can I do anything to the bottom? No, it's just x plus 3. I can't factor that any more than it's already factored, right? But on the top, how can I factor this? I've got to do the same thing as the last time, right? I've got to multiply to the last number, and I've got to add up to the middle number. So I need to find two numbers that'll multiply to 15, 3 and 5. Those also add up to 8. So those are the two numbers that I'm going to be using, 3 and 5. Okay, so how am I going to write this? X plus 3, x plus 5. On the bottom, I still have that x plus 3. That hasn't changed. So now, what's the same on the top and bottom? What can I cancel out? It's those x plus 3s, right? So if I do that, what am I left with at the top? I have x plus 5. What do I have left on the bottom? Well, I don't have anything left at the bottom anymore, so I'm going to put a 1 in its place. I got to have that placeholder 1. Okay, so I've got x plus 5 on the top. I've got 1 at the bottom. That means we're dividing everything by 1, right? And if you divide something by 1, does that change anything? No, right? If you're dividing by 1, everything is going to stay the same. So my answer is really going to be x plus 5. And that's as simplest as I can get it. So I'm going to leave it like that. Okay. Let's try number 4 on the notes. And then I'll get into some classwork once we get done with 4 and 5. All right, so how about this one? Is there anything we can factor on the top? No. All I have is a 3xy. Is there anything I can factor on the bottom? No, not really. It's a 2xz. So I can't really factor anything, right? Now, is there anything that's the same on the top and bottom that I can cancel out? Well, yeah, it's this x right here, right? So I can cancel those out. And then what am I left with at the top? Just the 3y. And what am I left with at the bottom? The 2z. So that's it. That's as simplest as I can get it. And notice the 3 and the 2 have no factors in common, so I can't really cancel out the 3 and the 2. It's kind of hard to do that without writing it as a decimal, so I'm just going to leave it the way it is. 3 over 2. All right, let's do the last one on the notes. Okay, so I have something on top. I have something on the bottom. All right, let's see if we can factor these. So the easiest one to start with is on the bottom. Can I multiply to 25? Yes, I can. I've got to have a 5 and a 5, right? How about the negative 45? Can I multiply to that? Yeah, I need a 9 and a 5, right? But I'm multiplying to negative 45. So that means one of those two numbers has to be a negative. And how do we figure that out? We look at the adding number, right? I'm trying to add to negative 4, but multiply to negative 45. So if I'm adding up to a negative 4, doesn't the biggest number have to be the negative, right? So I'm going to put that negative on the 9. So I got x minus 9, x plus 5. And then on the bottom, I have x plus 5 and x plus 5. All right, so what's the same on the top and bottom? The x plus 5s, right? If I cancel out 1 at the top, I can cancel out 1 at the bottom. So when I'm done, that just leaves me with x minus 9 over x plus 5. And that's it. Can't do anything else to it. Now, some people make the mistake of getting to this end part and they say, oh, well, look at these two x's right here. They're the same. So can I cancel those out like this? Let me change my color. Can I just do this, right? And the answer is no, you can't do that because look, that x is connected to this 9 by subtraction, right? If you look at the bottom, how is this x connected to this 5? It's connected by addition, right? You can only cancel them out if they're connected by multiplication. And that's what I have over here, right? So look at where my finger is pointing. How is this x minus 9 connected to this x plus 5? It's connected by multiplication. That's what the parentheses tell me, right? And look at the bottom. How is this x plus 5 connected to this x plus 5? By multiplication. If they're connected by multiplication, I can cross out those factors. But if they're connected by addition or subtraction, like over here, I've got to leave it the way it is, right? So my answer is still going to be x minus 9 over x plus 5. I can't factor anymore. I can't cancel out anything, right? So I got to leave it like that. Okay? Let's look at the classwork that we're going to be doing today. Okay. There we go. All right, let's do a couple. I'll start off with number 2. X squared plus 6x. On the bottom, I have x squared minus 2x. Okay, so how can I factor the top and how can I factor the bottom? That's the first thing I think about. So when I'm looking at this, I don't see any term that's connected on the outside, so I can't do the multiplying and adding thing that I like to do. But what do they all have in common? Both of these terms have an x in common, right? So I can take out the x. And that's what I'm going to do. So what am I left with? Well, I took out 1x. To get back to 2x's, I need one more x, right? So I'm going to put that x on the inside. Keep the sign the same, so I'm going to put down a plus. And since I took out the x, all I need is a 6 now. All right, so that's the top. How about the bottom? What can I take out from both of those? Same thing, right? I can take out this x. When I do that, I'm left with x minus 2, as you probably guessed. So now, what's the same thing on the top and bottom? It would be that x. So I can cross those out. And then what am I left with? X plus 6. On the bottom, I have x minus 2. And that's it. I can't do anything more. So that's number 2. Let's do number 4. So we're skipping around. Number 4. Let's see, I got x minus 2 on top. And then on the bottom, I have x cubed minus 8. All right, so on the top, that x minus 2. I can't do anything with that, so I got to leave it the same. How about the bottom? These are cubes, so I start off by finding what are called cube roots. So what's the cube root of 8? And what's the cube root of x cubed? That's what I'm trying to figure out. Cube roots. So the cube root of x cubed would be just x. So I bring down my x, and the cube root of 8 would be 2, right? Because 2 times 2 times 2 equals 8. And I bring down the same sign to start off with. All right, so the long factor, I start squaring things. So if I square x, I get x squared. If I square the 2, I get 2 times 2, that's 4, right? And now in the middle, I multiply the two parts together. So what's 2 times x going to give me? 2x. And then lastly, SOAP comes in. If I start off with a minus, then I'm going to change it to a plus. That's what the O means, opposite. Then the last two letters, AP, that stands for always positive, so I put a plus down. All right, so that's how I factor the bottom part. So let me write it up here. X minus 2, x squared plus 2x plus 4. All right, so now what's the same on the top and bottom? The x minus 2. So I can cross those out. What am I left with at the top? Nothing, so I leave a 1. What am I left with at the bottom? I've got x squared plus 2x plus 4. I can't do anything with this because, remember, you can't factor the long part, so I'm going to leave it like that. Okay? All right, I'm going to skip 5, and I'm going to go directly to 6. So let's look at number 6. All right, on the top, I have x to the 8th power. So that means I have 8 x's. I have 2 y's. And I have 3 z's. On the bottom, I have 5 x's, 7 y's, and I only have 1 z. So you could write it like this, or you can write it like this with a 1 on top. That's the same thing. I only have 1 z, right? So now what I do is, if something is the same on the top and bottom, I can cancel them out. What this is going to look like is the smallest number is going to get canceled out. So whatever the smallest number is, whether it's on the top and bottom, it's going to be canceled out. And I'm going to take them away from whatever the bigger exponent is. So let's say I have 8 x's on top and I have 5 x's on the bottom, right? I can get rid of 5 x's on the top and bottom. So I can get rid of all 5 x's on the bottom. But if I get rid of all 5 on the bottom, that means I need to get rid of 5 at the top. So if I have 8 x's and I take away 5 of them, how many x's do I have left? Well, 8 minus 5 is 3, right? So I'm going to change this into a 3. Let's do the same thing with the y's. I have 2 y's on top, and I have 7 y's on the bottom. So I can get rid of both of those y's at the top by doing this. So both of those are gone. But since I had 7 y's at the bottom, I need to take away 2 from 7. That's going to give me a 5. So let me change this to a 5. Okay, now the z's. If I get rid of 1 z at the bottom, I've got to get rid of 1 z at the top. So the 3 is going to change into a 2, just like you thought it would. Okay, let's see what we have left on the top. The only thing I have left on the top is 3 x's. So 3 x's and 2 z's. On the bottom, what do I have? Well, I got rid of all the x's and the z's. The only thing I have left is 5 y's. So let me put that on the bottom. And there's nothing more to cancel out, so I'm done. That's number 6. All right. Let me go to number 7, since that's a rainbow question. And I know people are going to have questions about that one, so I definitely want to cover that before I leave. Let's do 7. And this is probably going to be the last one that we're going to be doing together. So for 7, I have, let me pull it up a little bit. I've got 6x squared. I've got a 7x, and I've got a 2. And on the bottom, I have 2x squared, 5x, and a 2. All right, so this is a rainbow question. How do I know it's rainbow? It's because the number out in front isn't 1. If these were 1s, then I could just multiply to 2 and add up to 7. But there are no 2 numbers that add up to 2. I mean, multiply to 2, but add up to 7. So I can't do it that way. I've got to start by drawing the rainbow. So let's do that. So if I draw the rainbow, what's 6 times 2 going to be? That's going to be 12. At the same time, I've got to add up to 7. So can you think of 2 numbers that multiply to 12 but add up to 7? Let me put my MA down. So I've got 6x squared. I need to bring that over. And I can break up that 7x into 3x and 4x. So that's the way I'm going to do it. You can do it the other way, right? You can put the 4x first and the 3x second, but I'm going to do it this way and see how it works out. It should all give me the same answer anyway. Now, at the bottom, I still have to do rainbow because I have a 2 out in front. So I draw the rainbow from the first number to the last number. 2 times 2 is going to give me 4. So that's what I have to multiply to, and the 5 is what I have to add up to. So can we think of 2 numbers that multiply to 4, but at the same time add up to 5? Yeah, we're not going to choose 2 and 2, but we're going to choose 4 times 1. So I can break up the 5x into what? 4x and 1x? All right, so now I can group the first 2 terms, and I can group the last 2 terms. So it's basically going to look like this. I'm going to have 2 groups. Now, I think, what's the GCF in the first pair? So let's take a look at that. Right here, I can divide both of those by 3, and I can take out an x. And I'm left with 2x plus 1. How about over here? I can take out a 2, right? And I'm left with 2x plus 1. That's good. The inside parts match up. All right, now let's do the bottom. What can I take out of the first group at the bottom? I can take out a 2 and I can take out an x, right? So that's what I'm going to take out. And I'm left with x plus 2. That means whatever I take out of this second group right here, I better take out a number so that I'm left with x plus 2. And it turns out the only thing that I can really take out would be a 1. That's the only way I can make this work. And I am left with an x plus 2. That's good. They match up. The inside parts always have to match up when you do rainbow. Now we regroup. We take what's on the outside and we put them together. So 3x plus 2. And the inside parts were what? 2x plus 1. Okay, so I'm done with the top. The bottom is going to be 2x plus 1 and x plus 2. All right, so I can't do anything more to it. Now I just think what's on the top, what's on the bottom, that's the same. The 2x plus 1s, right? So I can cross those out. And what am I left with at the top? The 3x plus 2. What am I left with at the bottom? Just an x plus 2. And I'm done. There's nothing else I can do.